Hey guys, welcome. Yeah, so as per promise, properties of sigma here, and this first property is something that I already clued you into through a small example in the intro video to sigma notation. There, we had a constant 5 inside of sigma, and n was 3, and what we said was that like when k equals 1, we assign the value 5 because there's no k in here, right? And so similarly here, when k is equal to 1, we assign the value c, and then we go plus. When k is equal to 2, we assign the value c, and then we go plus. You get it. For every k, we assign the value c, including the very last k, which is when k is equal to n, we assign the value c. So in total, we will have n c's, and therefore, c plus c plus c plus dot 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 plus c, when there's n of them, by definition, is c times n, as multiplication is repeat addition, right? Okay, cool. Second property, whoa, I lied. So the example first, and this, as I said, is something we've already seen. K equals 1 to 3. So when k equals 1, we assign the value 5, plus when k equals 2, we assign the value 5, plus when k equals 3, which is where we have to end, we assign the value 5. So we have 5 plus 5 plus 5, or 5 times 3, which is 15. Yeah? And that's what we said in the intro video to sigma notation, that this is 15. So stay consistent. All right. So property 2. Property 2 says, what if inside of sigma we have a constant times an expression? So the expression I'm representing by a sub k here. A sub k could equal k squared. It could equal just k. It could be something fancier. But yeah, a sub k is the expression, and we're multiplying the expression by c. Well, it looks like we could instead take out the c in front of sigma, first add, and then multiply by c. Notice that all this says is that distributive property of multiplication over addition works, right? And we've been familiar with that for a while. We know that the distributive property works. And that's all that this is saying, essentially. It's just masked as a sigma notation statement. It's really about the distributive property of multiplication over addition. All right. I was so eager to say that I stuttered, but I'm going to continue and keep this video. The example here is going to have us start with this, which is, what if we had 5k inside sigma and we went from k equals 1 to 3? Well, if we kept the 5 inside of sigma, then when k is equal to 1, we'd have a 5, and then we go plus. When k is equal to 2, we have a 10, plus when k is equal to 3, we have a 15. So 5 plus 10 plus 15 is 30. The other thing we could do, based on the property 2, is take out the 5 in front and then add first and multiply by 5, right? Okay, cool. Well, if we add first, we'll have, and there's no 5 inside sigma, we'll have k equals 1, so we have 1, plus when k equals 2, we have 2, plus when k equals 3, we have 3, and we end there. So we have 1 plus 2 plus 3, but then we have the 5 outside multiplying our sum here. So we have 5 times 1 plus 2 plus 3, since 1 plus 2 plus 3 is 6. 5 times 6 is 30. So this property is demonstrated through this example, yeah? All right, so our third and final property in this video is this guy. And here it says, what if we have two different expressions inside of sigma? Well, it looks like you can assign a sigma to each of the expressions inside of sigma, right? That's what this property says. All right, cool. So an example, let a sub k be the expression 2 to the power of 3x, and let b sub k be the expression negative 5 to the x. And we're going from x equals 1 to n, then this is what it would equal based on this property, and yes, it's true. Okay, so the next video will be about double sums, which in theory you could just list as property 4 and the properties of sigma. So it's technically a property of sigma, but it's interesting enough, it's different enough, and it's sophisticated enough that it deserves its own video. So the next video is a fourth property of sigma, and it's going to be called double sums in the next video. Sigma notation, double sums. Yeah? Cool. All right, look out for that video. Keep watching. Take care.